this lesson, we are looking at the slopes of parallel and perpendicular lines. Now we're going to start with parallel lines here, and parallel lines are lines in a coordinate system that never intersect. You'll notice that here we'll draw a line between them. This is the distance between these two lines. The distance between them is going to be exactly the same. That's the meaning of parallel. So these two lines are parallel. Their distance between them never changes. Now parallel lines have slopes that are the same because they rise and fall at the same rate. Let's take a look at that. We're going to look at this line first. So we'll call this L1. We're going to take a look at the slopes here. Now you can choose any 2 points that look like they fall on an integral point. So we could choose this point, for example, and this point. It doesn't matter which two we choose. I'm going to call this point, point A, and this point, point B. Now A has a x value of -3 and a y value of 4, so -3, 4. And B is -1, I'll write that over here, -1 and -2. Now we can use the slope formula to find the slope between these 2 points, or we can simply count. Now we notice that the change in x here is 2, so this is the change in x is 2, and our change in y, we're falling as we read from left to right, so 1, 2, 3, 4, 5, 6, so our change in y is -6. So the slope of L1, this is the change in y over the change in x, is -6/2 or -3. Let's do the same thing now for this other line. This we'll call L2. And again, you can choose any 2 points here. Let's choose this point and this point. So we're choosing something different than L1. So this is, we're going to call these C and D. And C has a x coordinate of 2 and 1 for y. And D, this is 4 and 1, 2, 3, 4, 5, -5. Okay, and again we can use the slope formula for finding the values, or we can simply count. There is a change here in x. Here is our change in x, and our change in x is 2 units. Our change in y, again, we're falling. So our change in y is 1, 2, 3, 4, 5, 6. Our change in y is -6. So again, you'll notice that the slope, this is L2, the slope of the line L2 is the change in y over the change in x, which is -6/2 or -3. So you'll notice that these two slopes are exactly the same. Now let's take a look at the slopes for perpendicular lines. Perpendicular lines are lines that intersect at a right angle. So here, this is where these two lines here, they intersect, and this is a right angle. You could draw a little square between them to show that that is a right angle. Now these, the slopes of perpendicular lines are negative reciprocals of each other. Now let's go ahead and take a look at that. I'm going to label this line L1 again. And let's choose 2 points here and look at the slope of these 2 points. So here is 1 point here and another point here. I'm going to call this A and B. And the slope here, this has a change in x of 1. And our change in y, again, we're dropping, so our change in y is negative, and it's 1, 2, 3 units. So our change in y is -3, 3 units down. Now let's take a look what happens when we take this line L1, and essentially it's being rotated 90 degrees. Here's our little 90 degrees again, 90 degrees, and here is our line L2. So here let's take a look at 2 points here. And you'll notice here, this is our change in y now. This is our change in x, given those 2 points. And what's happened is that our change in x here, as we rotate this 90 degrees, becomes our change in y. So our change in y now is 1. And we're rising from, as we read this from left to right, so this becomes positive. Our change in x, again, as we rotate here, our change in x is simply what our change in y was. So as we rotate that line 90 degrees, this here, this value here, becomes this value here. So, but now it's positive because we are rising. So this is 3. So our slope for L2 is 1 over 3, and our slope for L1 was negative 3 over 1, or just negative 3. And you'll notice that these two are negative reciprocals of each other. This one is negative, this is positive, and they are reciprocals in that the numerator and denominator flip. That's what a reciprocal is. So the slopes of perpendicular lines are negative reciprocals of each other.